Imagine telling a tech bro in 2026 that generating Hollywood-quality 2K AI video in their living room doesn't require a massive cloud server.
Yeah.
Or even, a brand new graphics card.
Right, yeah.
It's actually all about a dusty 6-year-old gaming GPU from 2020. So welcome to today's deep dive. We are looking at a stack of technical architecture guides and economic breakdowns specifically focused on the Indian market.
Exactly. And just to be clear right up front, we're simply reporting what's in these sources. We aren't taking any sides or endorsing any specific hardware brand or viewpoint here. We just want to convey the ideas.
Yeah, perfectly said. Our mission today is to map out exactly how you can run massive models like FLUX or WAN 2.2 at home without bankrupting yourself. Okay, let's unpack this.
So the entire landscape has shifted. We aren't really chasing processing speed anymore. I mean, it's all about memory now.
Right.
The real bottleneck that stops these open weight models cold is VRAM capacity.
Yeah, think of VRAM like a giant kitchen counter. Processing speed is just like how fast your chef chops vegetables.
Exactly.
But if you're trying to bake a 32 billion parameter wedding cake, you need a giant counter. If the cake doesn't physically fit, the chef can't even start cooking. The whole system just instantly crashes.
You've hit on the exact bottleneck. The industry calls it a fatal out-of-memory error.
Oh, wow.
Yeah, because before you even generate a single frame, just loading the foundation models consumes immense space.
But wait, here's my pushback on that. If you need that much counter space just to load the model, how are you supposed to generate native 2K video on a standard 16 or 24 gigabyte graphics card?
Right.
I mean, the cake shouldn't fit. The math just doesn't add up.
Well, what's fascinating here is you don't.
Wait, really?
You absolutely avoid generating native 2K. If you try, you hit that memory wall instantly. So the workaround from the sources is an orchestration pipeline called Comfy UI.
Right.
Instead of baking the whole cake at once, you generate the base video at a very low resolution, like 720p with a low frame rate.
Ah, so you're basically sketching out a rough draft first, just to get the composition and motion locked in.
That's the first step, yeah. Once you have that low-res base, you pass it through specific nodes for frame interpolation to smooth out the motion.
Right, making it look fluid.
Exactly. And finally, you use AI upscalers. These secondary neural networks analyze the low-res video and mathematically hallucinate the missing pixels, inflating it into brilliant 2K resolution.
Oh, so you isolate the heavy lifting so your GPU never gets overwhelmed.
Yes, you're basically cheating the system.
Right, but your computer still needs a very specific physical architecture to handle that handoff, right? Between the low-res generation and the high-res hallucination.
It does, definitely.
Which makes me wonder, Macs have unified memory. They essentially turn the whole system RAM into one giant kitchen counter. That sounds perfect. So why aren't we using Macs? Here's where it gets really interesting.
Well, on paper, Apple's unified memory is a total dream for loading large models.
Yeah.
But these AI pipelines are deeply optimized for NVIDIA's Hudia compute architecture. Without those specific CUDA cores to handle the tensor math, Apple Silicon just struggles to push the actual generation through at an acceptable speed.
Which leaves us looking at NVIDIA cards. But looking at the economic breakdowns for the Indian electronics market, a brand new RTX 5090 is suffering from extreme markups.
Oh, it's completely wild.
Costing a staggering 4.6 lakh rupees. You can't build a budget home studio with that.
You absolutely can't, and that dictates a very counterintuitive strategy. The ultimate financial hack, the undisputed king of 2026 AI in this market, is actually the NVIDIA RTX 3090.
A used card from 2020.
Yeah. You can grab one on the secondary market for about 60,000 to 75,000 rupees, and it gives you 24 gigabytes of VRAM. It provides the necessary counter space at a fraction of the cost.
Okay, so I get the used GPU, but the research also emphasizes a huge supporting cast. Like it says you absolutely need 64 gigabytes of fast DDR5 system RAM.
Yes, definitely.
Which makes sense for temporarily storing inactive model weights, like the parts of the AI you aren't using right this second. But why does it also demand a 1,000-watt ATX 3.1 power supply?
Right.
We aren't mining crypto here.
It comes down to how AI generation utilizes the hardware. Unlike normal gaming where the load kind of fluctuates, generative AI suddenly commands every single compute core on the GPU.
Oh, all at once?
All at once. They perform massive matrix multiplications at the exact same microsecond. This draws an immense gulp of power instantly.
A massive transient power spike.
Exactly. And if your power supply can't handle that sudden surge, your system just shuts down mid-generation.
Man. So what does this all mean? It means if you want to build a hyper-realistic AI generation studio at home, you have to prioritize VRAM capacity over raw compute speed.
Right.
You lean heavily on comfy UI upscaling pipelines to cheat the resolution limits, and you need to buy smart, older hardware to make the economics work.
And this raises a really important question for you to mull over. If a single used gaming card from 6 years ago can effectively replace a multi-million-dollar proprietary cloud data center today, what happens to the global AI monopoly when developers finally figure out how to seamlessly network all our individual home machines together?
Into a decentralized supercomputer. Talk about expanding the kitchen counter. Suddenly, the entire world is the counter space.